My name is Luciano Chiang, and in this video I will show you 3 ways to control the speed of a DC motor by PWM pulse width modulation. These 3 ways are classical ways of controlling the speed of a motor by pulse width modulation. I have implemented the 3 of them, and I will show you the advantages of disadvantages of each one. Okay, what is PWM? We have a DC motor here, and we have this power transistor which is saturated or opened by a pulse width modulation signal, which is shown here. Now, in this video, we will show 3 ways of generating these pulses. What happens then is that the current flow from the power supply down to ground will be interrupted by these pulses. So when the transistor is saturated, the current will go through directly through the motor towards ground, and the pulse that the motor will be this square pulse, this voltage. Now the current in the motor will reach an average, which is shown in the red line, and it will grow on the on part, and it will decrease on the off part. And it will decrease in the off part when this transistor is turned off, because the current that is going through the motor will start returning through the flyback diode and start circulating this way. And the current will decay by an exponential decay. And as soon as this transistor is turned on, then the current will restart flowing down to ground and will growing. It would have an exponential growth. So in this way, the voltage applied would be this square pulses, and the current will follow this exponential growth or exponential decay. And in the end, you would have an average current through the motor, and that's what the value of the average current is what will keep a certain level of rotational speed. The frequency is given by this formula, and the duty cycle is given by the percentage of the time that the transistor is closed divided by the total cycle time. So you can have from 0% duty cycle to 100% duty cycle, and at 100% you're at full velocity, and at 0% the current will not flow through the transistor, and the motor will not rotate. And in between, values in between will give velocity in between these two boundaries. And I also used in these circuits that I will show you next, LED which will dim according to the level of duty cycle, and a transistor here, a capacitor that I use to eliminate noise, because these small DC motors that I will use for testing these PWM circuits are very noisy, so you need a capacitor to eliminate the noise. So if you have like digital circuits here, it doesn't generate noise, and the circuit could malfunction. Okay, the methods that I will cover here are: 1 based on the 555 timer circuit, then the second based on the 741 op amp, and the third based on the Arduino Uno. And I think these are 3 or probably the most simple ways of generating the pulse modulation cycle. Here I show the 3 ways that I will show and discuss here. This is done by an Arduino, which would be this setup. And here's the Arduino, and here's the setup, the transistor setup, and here's an LCD display so that I can show the value of the pulse width modulation. And here I have the 741 op amps set up, and here's the timer 5581. So you can see that the 551 is the simplest one in terms of components, and the Arduino is the most complex one, but also you have to consider in this latter case that you buy everything you can buy and just assemble it, and it's very simple to assemble. Okay, the DC motor that I will use, the DC motor assembly is this one. I have a motor, a gearbox, and the noise filtering capacitors that I talked about earlier. And then I have this setup in which I have a reed relay magnetic switch and this magnet. So every time every one revolution, this magnet closes the reed magnetic switch, and this I read using a tachometer, which is Arduino-based tachometer, which I will show how to implement in a future video. Conclusions. Here I have the three curves, one next to the other, and you can see the one that has the best range is the one based on 741, and the Arduino Uno seems to have a lower performance, but this is probably because pin 5 does not source enough current to saturate the transistor completely. And but you could fix that, but it'll generate a slightly more complex circuit. And the blue one is the one with a 555 timer. As you can see, the pulse width modulation is not linear, so you cannot expect an open loop, a good open loop control of speed. And also you don't have the full range of speed. You cannot reach lower than, for example, in this case, around 20 RPM. These are not the RPMs of the motor, but these are the RPMs at the output of the gearbox. And the gearbox in our test has around 200 and something reduction index. Summary. There we have tested three methods: the open loop speed control of a DC motor. The RPM of the motor is not linear with respect to the pulse width modulation. The 551 implementation is the simplest starting from scratch, followed by the 741 solution. Arduino-based PWM gives more flexibility for additional and expanding applications. And if you have an Arduino already, it's easier and faster to implement. The 555 implementation will generate a full range of PWM and will reach from around 50 to 90% in our case. Arduino base gives less performance probably because it cannot source enough current to saturate well transistors such as the one we've used here. Okay, thank you very much, and I hope that's been useful for you.